Hello and welcome back to IXL tutorials. This is Mr. Duffick. And today I thought I would do a kind of a rehash of IXL R10 for geometry, kind of similar to R8 and R9, the updated videos that I've done without using the special right triangles. Thought it would be a good idea to do one for R10 as well because we are not doing special right triangles until later on in the unit this time. And so I thought I would give you guys an explanation of how to do these problems without using special right triangles. Alrighty, so I tell my students that these problems are just a mixed review of IXL's R8 and R9 because R8 had you finding the missing sides while R9 had you finding missing angles of right triangles. For these problems on R10, they're just asking you to find everything really. You have a right triangle, they give you one of the sides, which is nice, and they give you two of the angles. They give you V as the right 90-degree angle and U as the 60-degree angle. And then, of course, they're asking you to find your last missing angle of W and then the missing sides UW and UV. Okay, and we're just going to use the same methods, really, that we did for the other two IXLs. And so to do that, we'll go ahead and identify what's important, which is pretty much everything here, right? But let's pick a couple sides here. They give us 60 degrees, so I'm going to call this theta. And forgive me, my drawing pad is out today, so I'm going to be using my mouse. Could be a little sloppy, but such is life. Alrighty, so we have the theta right there for angle U, or 60 degrees. And now let's go ahead and pick a side to solve for. For reasons that we'll get to in a little bit, we'll be using the unit circle for these problems. And we're going to want to stick with cosine and sine as much as possible to make it easier on us. And so if we make 60 degrees our theta, we can label side VW, or 27 square root of 11, as the opposite side. Right? And since we know sine is opposite over hypotenuse, we will go ahead and try to solve for the hypotenuse, which is right here. Okay, we'll have to solve for the other side, the adjacent side, later. But since we already know what the opposite side is from our designated theta, we'll go ahead and use sine because we know sine is opposite over hypotenuse. Okay, so we'll do sine of 60 degrees equals opposite side is 27 square roots of 11 over the hypotenuse side, which is UW. Alrighty. Now, we want to solve for side UW, right? So we'll have to get that all by itself. Initially, since UW is on the bottom over here of this fraction, what I recommend is multiplying both sides by UW, so it's right up top. There's a couple different ways you can do it, but that's what I recommend. We'll do UW. So since we're dividing by UW, we got to do the opposite to get rid of it, which is multiplication. So we'll multiply that right side by UW. But since we are multiplying the right side, we now have to multiply the left side by UW as well. Alrighty, so the UW's are going to cancel out, which is why we did that. And now all we have is UW times sine of 60 Alrighty, and that is going to be equal to, since the UW is canceled out, all we have left is 27 square roots of 11, or in other words, 27 times square root of 11, same thing. Okay, now we still have to do one more thing to get UW by itself. We're going to have to go ahead and divide the entire thing by sine of 60. Because sine of 60 is sort of standing in our way when trying to get UW by itself. So since we have UW times sine of 60, we got to do the opposite of multiplication, or times, which is division. So we'll go ahead and divide that whole thing by sine of 60. And because we divided the whole left side of that equation, we have to do the whole right side as well. So sine of 60. Alrighty. The sines of 60 cancel out, and we are left with UW equals 27 square roots of 11 all over sine of 60. Okay, and this is where it really starts deviating from what we were doing in R8 and R9. So for those IXL problems, and specifically R8, all we would do is type in sine of 60 into a calculator, take the number it gave us, and put it in for our answer, right, after we did all the math. Well, for these problems, for R10, it's asking specifically for answers in the simplified, rationalized form, meaning we're going to have to keep everything within our square roots or radical forms. Okay? And so 27 square roots of 11 is already there, but sine of 60 we're going to have to convert into a number that contains, it's either a clean number or a number that contains a square root. And to do that, we're going to use what is called the unit circle. The unit circle. So let me change screens here real quick. Okay. All I did was Google a unit circle, and you have a bunch of images come up. And so here's one that I found, and I'll be using here. Hopefully your teacher has gone over the unit circle. It's going to make this a lot easier, but if not, no problem at all. The unit circle is one of those little diagrams that you can just use as a reference. You don't have to memorize everything. Usually you just have one in front of you, and you help it, or it helps you to identify what number you need. And so unit circle in a nutshell is this. We have a graph. We have the y-axis and the x-axis to the graph, right? And when you remember back to rotations from the transformations unit of geometry, you know that you start at 0 degrees over here at on the x-axis, and then you rotate up in the counterclockwise direction, goes to 90 degrees, keep going, you have 180 degrees, keep going, you have 270 degrees, all the way back to 360 degrees, and you can just basically keep going forever, okay? This unit circle has 0 through 330 or 360 degrees. Start at 0, we go to 30, then 45, 60, then 90, then 120, 135, etc., etc. Okay, and you notice at each of these locations, the 30-degree mark, the 45, the 60-degree mark, they each have an x comma y value associated with them, right? So let's look at sine of 30 here as an example. I'm sorry, just regular 30 degrees, not sine yet. Oh, believe me, it's coming. 30 degrees right here. When we have 30 degrees, we have an x comma y value. For our x value, we have the square root of 3 over 2, and we have comma 1 over 2 for the y, right? X comma y, and that's what we have. Now, the relationship here between these numbers and cosine and sine is that cosine is going to be referring to the x value of these coordinates, and sine is going to be the y value of these coordinates. So if we wanted to find cosine of 30 degrees, that's just going to equal the square root of 3 over 2, because cosine we associate with the x value. If we were trying to find sine of 30 degrees, then sine of 30 degrees is just 1 over 2, or 1/2, because sine is associated with the y value of our coordinate. Okay? Now let's go back to the problem here. When we go back to the problem, we want to simplify what? We want to simplify sine of 60 down into one of these numbers, right? So sine of 60, we'll go back to the unit circle, and we'll go to 60 degrees because we're trying to find sine of 60. And then since we're trying to find sine of 60 degrees, we're just going to look at the y value and call it a day. So sine of 60 degrees is equivalent to the square root of 3 all over 2. If we wanted to find cosine of 60, then that's just going to be 1/2. But since we're doing sine of 60, then that's going to be equal to the square root of 3 over 2. Meaning we'll just go back to our problem, and instead of writing sine of 60, we will go ahead and write the square root of 3 all over normal 2. So I'll just write it like this. On top, we still have 27 square roots of 11 all over. Sine of 60 now becomes the square root of 3 all over a regular 2. Okay? And so from here, we will go ahead and simplify this down as much as possible to get our final answer for the side UW, which is what we've been doing here first, right? Okay. When you divide fractions, you can think of it different ways. What I like to do is take the top, which is 27 square roots of 11, and turn that into a fraction of 27 square roots of 11 all over 1, right? All over 1 is just saying divided by 1. Anything divided by 1 is itself, so it's just kind of like an invisible 1 you can write there. So the top is 27 square roots of 11 over 1, and then the bottom of our big fraction is square root of 3 over 2. And since we're dividing in this case, we want to switch it to multiplication, and to do that, how I remember it is just switching the square root of 3 over 2 with each other. You're basically flipping the fraction and multiplying it. So we have 27 square roots of 11 over 1 now times, instead of divided by or over, 2 over square root of 3. We are flipping that bottom fraction, but now we are multiplying. We're not dividing any longer. Okay, it's kind of a fair trade-off there. So from there, we will multiply across here. 27 times 2 is going to be 54 times square root of 11. Just multiply that 27 and 2 together. And then on the bottom, 1 times square root of 3, just square root of 3. Okay. And now we are very close of being done here. We do still have a square root on the bottom, so we are going to have to multiply the top and the bottom by that radical, right? That's how we get a rationalized form. It's called rationalizing the denominator if you need more practice in it. But if we have a square root on the bottom here, we're just going to multiply the top of our fraction and the bottom by that same square root. So 54 square roots of 11 times square root of 3 is going to be 54. Now square root of 11 times square root of 3 is just going to be 3 times 11, which is square root of 33. All over. And then we have to multiply the bottom by our square root of 3 as well. So square root of 3 times another square root of 3 is going to be regular old 3. Right? And you can think of that as the square root of 3 times square root of 3 is square root of 9, and then square root of 9 is 3, or whatever, however else you want to think about it. Okay, and then we're just going to simplify 54 over 3. 54 over 3 simplifies down to just 18, right? 54 divided by 3 is 18. And so I'm just going to write 18 square root of 33. And that finally is going to be our side length for side UW. So I will go ahead and write that in right here. Okay. Now I'll write it in for the hypotenuse up here as well, just so it's easy to reference. Okay. So good news and bad news. Good news is we have our side length for UW, and we'll get to the missing angle of W later, but that one's really easy as well. Bad news is we basically have to do this one more time to find UV. Now you might want to find, or sometimes you might be able to use the Pythagorean theorem. Since we now have two of our sides, we can use Pythagorean theorem to find the missing one. The problem is with this IXL, since it wants you to have the answers in your rationalized or radical form, the square root, there is a good chance that you are not going to be able to do that with the Pythagorean theorem. You're going to get some whole number with a decimal. And so we basically want to repeat what we just did here. So we get our radical, and we can use the unit circle to convert and all that stuff, okay? This one won't be as bad, though. So we got to find side UV now. And so if we're doing theta as 60 degrees, we'll go ahead and label UV as adjacent, like that. And then again, you typically want to use sine or cosine. We already did sine, and since we know adjacent and hypotenuse is cosine, we'll go ahead and use cosine. So cosine of theta, or in other words, cosine of 60 degrees equals adjacent side. We don't know what it is yet, so we'll write side UV all over hypotenuse, which is going to be 18 square roots of 33. Okay, it's much easier to get this side by itself, UV. All we do is to multiply both sides by 18 square roots of 33 to get that UV by itself. And so when we do that, we now have 18 square roots of 33 times our cosine of 60, since we're just multiplying it both sides. Cosine is 60. 18 square root of 33's cancel out. And so all we are left with is just side UV, like we planned. Alrighty. Before we multiply 18 square roots of 33 together with cosine of 60, we should convert that cosine of 60 using the unit circle first. So we'll go back to cosine of 60, add our unit circle. Let's see, show that. So cosine of 60. We'll go to 60 degrees, and cosine is the x value of that coordinate. So cosine of 60 is just 1/2. That's a lot simpler than dealing with the other square roots. So we'll go over here. Cosine of 60 is 1/2. So I'm going to rewrite the equation here as 18 square roots of 33 times, and again, instead of writing cosine of 60 degrees, I'll go ahead and write 1/2 equals UV. UV. There we go. Okay. 18 square roots of 33 times 1/2. Well, 18 divided by 2, or half of 18, is 9, and so that's all we have here. So we have 9 square roots of 33. And that's the answer, right? A lot easier than that first one. Didn't have to deal with the radicals, but I thought it was important to do an example where you had to do some radical stuff just so you had some expectations about what IXL wants from you, okay? So we have 9 square roots of 33 equals UV. And so that is what I'm going to write in for our answer here for UV. We have 9 square roots of 33. Okay, and we are almost done here, and this is by far the easiest part. Now we just need to find the measure for angle W. The measure for angle W up here, right? They give us V is 90 degrees and U as 60 degrees. Well, what's W? Well, you know that all three angles of a triangle have to add up to 180, right? And so 90 plus 60 plus what is going to equal 180? And the answer to that is just going to be 30 degrees. Okay? If you've heard about special right triangles, you know this is a 30, 60, 90 triangle. Very easy to identify. But if not, just use your logic. What times I'm sorry, what plus 60 plus 90 is 180? And that's going to be 30 degrees. Okay? That one's pretty easy. So that is our answer, and this is what we would submit to IXL, and that would be correct. Alrighty? So that is where I'm going to end the video. I think that is long enough. But this is one of the harder problems you'll see, I think, that has to do with the radicals. Again, just use your principles from R8 and a little bit of R9, but really R8 to solve for your missing sides and maybe your missing angle. If you're missing two angles, you might have to use the R9 stuff with the arc or inverse functions, arc sine, arc cosine, arc tangent, all that. Just review R9 if you are missing out on that. Okay, but the big takeaway here, of course, is the unit circle. Make sure you remember to use the unit circle in order to convert your sines or cosines into other numbers or radicals. Alrighty? Take care, good luck, and goodbye.